introduce Walt Westfall for a few opening slides on cStor, and then we'll dive into our main event. Walt?
Well, good morning, everyone. Great to have you here for another cStor TechWise session. Just briefly for you folks out there, this is really a good opportunity for all folks to learn more about the world that we deal with in IT and cybersecurity and other areas, of course. Today, it happens to be about a company I'm very high on. That is Splunk. Real quickly, I'll tell you that really great partner, really great products, great company, a lot of energy, a lot of good leadership in this company, and it really results in a really good product and really a lot of energy and passion around what they do. And what they do simply is, you're going to learn about today about the security piece, but think about this. They do transactional data, they do machine data, they do reference data, they correlate all that into something that has value to your company. But then again, we're going to do the security piece today. A little bit about cStor. Obviously, we're established in 2002. Started as a small company, and now we're a good mid-sized boutique company and focusing on our clients and what they need to move forward in the digital world. This is our practice areas. What I can tell you today, you can consider most of this to be data center practices, which we all have and we do today. And where we're focusing right now is the ability to help you transform your business from a digital transformation perspective, a cybersecurity perspective, and also we're adding in the services piece to make all that happen for our clients. Today we have great partners out there. NetApp is part of this today's session. Great partner with Splunk. They are the back-end piece that Splunk lives on, so it's a great match between Splunk and NetApp. I already mentioned consulting services, so why don't we go ahead and just move in, and we're short on time. Let's just start with the teams. Kevin, I know it's a change in the weather up there. You live in my neck of the woods where I grew up in Seattle. Welcome to the sunshine, and I'll turn it over to you and Locke.
Awesome. Well, if you can't, I am Kevin Haynes from Splunk. I'm up in the Pacific Northwest out of Seattle. I service the state and local education customers up here. Today we are going to just drop right into a couple of security scenarios and how a security analyst day in the life might be with solving those challenges, and then I'll give you a little bit of a picture of how the bigger ballpark is around Splunk and what you can do, and not just using it for one use case, but for several use cases. So we're into our scenario here. So the good thing about any sort of attack on your particular entity is that it's not magical. The attacker actually has to do some work, and they have to touch multiple entities in your environment in order to actually enter the premises, virtually or digitally, and then land and expand, and then they have to do something to, for example, exfiltrate your data if that's their end goal. The point being here is that they have to touch multiple endpoints on your environment, and if you're monitoring those environments, you've got a nice, rich fingerprint of activity that we can walk through and find that activity, essentially pulling those needles out of this haystack of activity going on in your network. So we're going to talk today about the fact that this data can all be brought into one single platform. Obviously, I'm talking about Splunk today, but we're talking essentially about the system of record of the data in your environment. And we're going to use Splunk today to solve two particular security use cases moving forward. So here's just my one Splunk slide showing you the data here on the left flowing into the Splunk platform. It's both offered as both an on-prem solution and as a SaaS solution. And once that data is in the Splunk platform, you can start asking questions. Customers typically start by asking ad hoc questions, just learning what's in their environment, learning what's important in their environment. And they start monitoring those things and alerting on conditions that they want to know about. They can start reporting and analyzing that information, putting up custom dashboards so that they can watch in real time what's going on in their environment. So let's hop into use case number one. Use case number one is around sort of the land and expand model. So we have in our example here, we have some malware that's potentially rampant in our environment, meaning it's landing on particular clients, and one of its first modes of operation is to try and infect other devices on your environment. So getting out from the initial place of infection and moving on to other places. So here we have a particular client there in the center. On a typical day, day in the life of that client, it typically reaches out to, you know, a file server, a couple web servers, maybe a print server. It talks to about 10 hosts a day on average. Now that device gets infected, and so we now start seeing a pattern of activity where this device is now all of a sudden anomalously talking to many, many hosts that it doesn't usually talk to. So this is really our scenario that we want to be able to detect. So here we're stepping now into the world of Splunk. So here's a piece of what looks like pseudocode about looking for this activity in our network. This is actually Splunk search processing language, or Splunk SPL, which we're going to dive into and look at, and so we can piece out what we're looking for here. So for example here, we're asking for, hey, I want to look at, for example, my Palo Alto network traffic, and what I want to do with that traffic is I want to compute some statistics off of that traffic. So here we're computing two things. One is the distinct count, that's the DC, the distinct count of destinations, and you can see at the very end, by source IP. So for every source IP, I'm interested in calculating two things: the number of destinations that machine reaches out to, and also I want to see that as a histogram. I want to see a spark line of that same distinct destinations over time. So if I now hop to my Chrome browser, I can show you that search live here in Chrome. So you can see here that we're doing a few things with our traffic. So in addition to looking at that particular traffic and calculating some statistics, we're going to do a couple things. So we are interested in how the pattern of activity is different from one day to another. So we want to be able to detect that change. So here we're taking that the Palo Alto network traffic, we're breaking it up into one-day buckets, and we're computing our statistics again. Here we're computing the distinct count of destinations, and we're going to call that number of destinations. And we're doing this by source IP and by time, by day. And for that, we want to calculate both the average number of destinations, the standard deviation of that number, and then we want the latest. What is it now? And we want to do that all for every source IP in our environment. So you can see here on our environment, we're getting the picture of the average and the standard deviation for all the clients in our network. So what I want to do with this is I want to actually, and the other point is this demo is actually running on a network that to date doesn't have this malware running on it. But we're going to be able to show that right now nothing's running in our environment with this problem. So if I hop back and I add a condition to this search, so here's the actual detector part, and all it has is a clause at the end of the search to filter down to what we're interested in seeing. So you can see here, all we've added is a subclause to our particular search, which is only show me the results. Don't show me all the clients and all the statistics that you've collected. Only show me the instances where the latest number of connections is greater than two standard deviations away from the average. So as you can see now, we're not seeing any instances in our environment, which is a good thing. But we also want to be able to know when something does show up on this list. And that's actually very easy to do. So for example here, we could just save this search as an alert. And so we want to know if we have a breakout. for example. And so maybe we want to run this every hour. Maybe we want to run it in real time. It's completely up to us. Let's say that we want to run this every hour, and we are interested in knowing when there's anything on this list, so when the number of results is greater than 0. We can throttle this. If we're interested in, maybe we only want to create a ticket for this every 2 or 3 hours. So maybe once we get an alert, let's sleep for 120 minutes here for 2 hours. But each time there is an alert here, when there is a breakout, we can do one of many things. So for instance, maybe we want to run some or quarantine that host on the Palo Alto network. Maybe we want to open a ticket. Maybe we want to run a script. Maybe we want to just directly shut down that box. Maybe we want to send an email letting folks on the team know that there's a problem. We can decide what information is in that alert that comes to our email box. So immediately we are made aware of the problem. So I'm not going to say this alert since this is a demo system, but you guys get the idea. The other thing we could do is instead of having this come out as an alert, we could also just put this up on a screen in our data center. So maybe we want to create a dashboard panel here. We want to create our new ops dashboard, security dashboard, and we want to be watching for malware breakout. And we can create that dashboard. We now have a dashboard that we can hop right over to. We can put up on a screen in our data center, and we have a nice histogram here if there was anything there. So this isn't going to populate because there's nothing on the histogram yet, but you guys get the idea. Other things we could do, there's all sorts of interesting searches, by the way, that we could do. We could build up dashboards where we're watching for these sort of events and calculating severity. We might want to watch where IP addresses are coming to our data center from the outside world. But not only can we ask security questions, we can ask other questions of the exact same data that we're already bringing into Splunk. We can ask IT operations questions. Are we meeting our SLAs? Are our web tier, is it up? Are our applications running? Are we having failed transactions? What is the time between the different tiers in our environment? We can look at this as an executive roll-up for folks who want to have their fingerprint or have their finger on the overall look of the business. So with the same data that we're asking our security questions of, we can just ask different questions using Splunk SPL. So let me hop now back to the slide deck. We're going back to PowerPoint. And let me explain what we did here again in slides. So a consistently large amount of destinations sort of looks like this. So on a given day, this machine may have a lot of connections. They talk to, this may be a file server, maybe a lot of destinations, but in general, it's not spiking up. Maybe this machine was rebooted at some time during the day, but it's not on an upward trend relative to average. Inconsistent here is we are seeing something that looks anomalous, and that's what we want to know about. So we're just sort of reviewing what we just did. This was the search that we ran. We bucketed things by time, got the distinct number of destinations, calculated averages, and we filtered by where the average was, or where the latest was 2 standard deviations away from average. And here's what we would have gotten on a network that had such an outbreak. So we have a high standard deviations away from the average for these 4 particular devices. This is indicative, very simple search in a few seconds of 4 machines that are spreading malware. If some of you out there in the audience may be more math nerds than I, but we do want to make sure, and we obviously want to account for the fact that our average being calculated, we may not want to include the last 24 hours in our average calculation, because that average, that last 24 hours, may include the actual malware outbreak. So we actually want to exclude the last 24 hours when we're calculating our average. And this is just a snippet of SPL that says, you know, if the relative time that you're making the calculation is within the last 24 hours, don't include it in our average. This is just sort of a bonus slide. I'm now going to pivot to use case number 2, which is around data exfiltration via DNS. So this is the scenario where that malware has now landed, and it wants to do something bad. It wants to take data, for example, from your environment using a protocol which is wide open. So what is DNS exfiltration? So that malware does other things besides landing and expanding. It actually exploits when it's there. Maybe it has a keylogger, for example, and it's collecting logins and passwords. And that information, it just bundles into a little package that it wants to deliver, for example, with someone's credentials and password. This is just a text string. It takes that text string and it base 64 encodes that into a standard encoded message that can be decoded on the other side, but this is just an encoded version of that same text information. And we take that, and not do we try to pump it out of, you know, over a website or anything. All we do is we attempt to look up a host name with that packet of data, and then some domain where we're collecting that information. So for example, .attack.com. So attack.com is the authoritative source for those DNS entries for that domain. So DNS queries against attack.com are all going to go to attack.com's DNS server. That DNS server is obviously, if you're an attacker, going to be collecting these queries, and now it has just encoded payload with folks' credentials on your network. So this isn't fantasy. There is actual malware packages out there hackers can use and add to their own software to do this sort of stuff. So this is real world stuff we're talking about. The problem with watching this is that DNS data, it's an ocean. There's so much of this traffic going on a daily basis, minute basis, second basis in your environment. Monitoring this stuff is not something you could ever do by hand. You need a tool like Splunk to do this. So to do this in Splunk, we're going to take advantage of a free app, which is just an add-on, which gives us a couple little utility functions that we can use on the search bar. Two of the particular ones that it does, so it parses a given URL, and it does two things. It pulls out the subdomain, which is the part in front of the actual domain name. So in the example here on the slide, we're going up against defcon.org. But the subdomain in this particular example is nsa.gov.openwifi. That's the part that would have the payload. So the subdomain would have the payload. It also can compute something that's called a Shannon score. A Shannon score is effectively a computation of randomness of a particular string. So for example, 5As.com has a Shannon score that's around 2, a little bit less than 2. Google.com has a Shannon score that's about 2.5. Things that are over 3 are basically look like complete randomness, effectively encoded payload, for example. So we might look for URLs. We can look for URLs that have high Shannon scores over 3. So here's a sample SPL query for looking through our Bro DNS data. And we take each of the queries in that Bro DNS, and we parse it using our URL toolkit, and we compute a Shannon score for the subdomain portion, so that portion that would contain the payload. And then we evaluate a couple other things. We get the sublength, so the length of that subdomain string. and then we just put this on the table so we can look at it. So here's an example running that. So we're looking at our bro data, and for the last few minutes here we see we've got our domains, each of the subdomains associated with those domains. We see the associated Shannon scores, and we see the length of those subdomains. So let's now do some filtering. So here we've got the same search there in the middle there, but at the very end you can see that we're going to now filter this. So given that table we just looked at, we piped out to a search, and we search for a couple things. We search for the average Shannon score is greater than 3, the average sublength, so the length of the subdomain is greater than 20, so that would match a payload that's a base 64 encoded string. We also want to make sure that that string is relatively constant. So base 64 encoding always gives you sort of a consistent string length. So we want that sublength, that standard deviation, to be low. So running that, immediately pulling out of the ocean of data, you get a couple of drops showing you 2 particular domains that you have DNS queries going to that have high Shannon scores. The length of the subdomain is relatively long, here about 35 characters, and that deviation of that length is relatively low. And you can see on the samples there, that looks exactly like payload enclosed data that's being sent up in DNS queries to moo.com and chickenkiller.com. So that data has now been exfiltrated from our environment, but we can go after it. We know where that information is now coming from. I wanted to thank you guys, and I'm going to let cStor take the ball back. Thank you.
Yeah, I think that as long as the realities of this is real world scenario around getting data out of your network and being able to identify malware without relying on even your endpoint protection malware environment, that Splunk really brings a lot of these things to the table, and a lot of this is baked in. There's over, I think, 400 free applications to plug in across your environment to be able to do this pretty much out of the box with a little bit of tuning. But it's a pretty amazing tool.
Yeah, I'll add to that. I think the flexibility and the flexibility of this tool is pretty powerful. I think one of the key things is what is already built that you can leverage to make it simpler for someone to modify or someone to use in their environment. Kevin, I don't know if you can say a word about that. How do people get, learn this? How do they get more engaged in it? How do they make it simpler and quicker to market?
That's a great question, and obviously every customer is going to have sort of their own sort of path to sort of picking this tool up and using it. I was a former customer. 2 things. One is that what I loved about Splunk is how community-driven the company is. We have a rich environment of vendors and community members that contribute back what are called apps that are encapsulations of this sort of domain-specific knowledge. You could have an app that's just around hunting malware that has this collection of dashboards and searches and reports. The other is the education from Splunk is really tailored towards the end customer. The virtual sessions that you can take in the education is a half day. So obviously folks have other work to do during their day. So they're half day sessions where you actually have a full instance of Splunk made available to you in the cloud that you can get hands-on with the tool. So as a customer, it was just both who I could talk to and who I could learn from, and also the resources that Splunk brought to bear to help me learn.
Awesome.
Great. Just one additional part for. I'm sorry.
Oh, sorry.
I talked about it. Hey, I just want to make one more comment. From a cStor perspective, we've invested a lot of resources into Splunk as well, and Locke is one of those key resources for cStor. And if anybody has any questions, certainly give him a yell.
That was a great softball to the few questions that we do have. Thanks, Walt. We do have a couple. We'll squeeze them in. First question, Kevin, your demo showed the DNS exfiltration uses Palo Alto data. Do I need Palo Alto hardware to do this?
So the actual DNS one was using Bro data. So basically, Splunk is completely vendor agnostic. Obviously, you would need to have a data source flowing into Splunk that had the DNS query information in it. But no, there's no specific type of technology you need. We'll be able to leverage whatever in your environment, whatever you're using today.
Great, thank you. We'll squeeze a couple more questions in. I know Splunk has premium solutions that are essentially add-ons. I think you referred to that recently, late in the presentation, Kevin. Do I need any add-ons to do what you demonstrated?
Another great question. So to do what I showed today, you do not need absolutely any other premium applications on top of Splunk. This is all done using the core enterprise version of Splunk. The premium apps are essentially bundles of useful dashboards, alerts, reports, and a lot of knowledge information prepackaged for you. There is absolutely nothing that keeps you from building out the pieces yourself if you wish in the core product.
Great, thank you. One last question. How long does it take to get this type of data info into Splunk?
Data ingestion is, so the most frank answer to this question, it really depends on the source of the data you want to bring in. Some vendors, they have very readily available ways to get the data out of their solutions. And Splunk can consume them in a variety of ways, directly off the wire, through syslog, through what's called a universal forwarder. Some vendors have, it's a little harder because they don't want to share that information with the rest of your infrastructure. But again, Splunk is very agnostic about the way the data comes in, and we have many ways to facilitate the collection of that data.
Great. That concludes our event for today. Thank you, everyone, again, for your time and attention, and to our guest speaker, Kevin Haynes of Splunk, and of course to Walton Locke from cStor. Hope everyone has a great day, and we look forward to seeing you on a future cStor event very soon.